My name is Jonathan Hardy, and I'll be your conductor this evening for Austin on Rails. Welcome to Austin on Rails May 2014. If you don't know what that means, you may be in the wrong place. And I am off airplay. This is a lovely beginning. Anybody got any good jokes?
There we go.
There we go. Okay. As I said, my name is Jonathan Hardy. I'm the Director of Software Development at PeopleAdmin. That is not me, but it was a choice between that and probably a drunken picture of me singing Wilson Phillips at our most recent client conference, so I chose that. Apparently it's been going around, and so you can ask somebody about that later. I'm the Director of Software Development. I started there several years ago as a developer and got talked into being the director eventually. So now I went from individual contributor on a very valuable product to asking everybody if they're done yet. So whether that tells inspirational or cautionary, I'll let you be the judge. This is the first Austin on Rails back after a good RailsConf. Who went to RailsConf this year? Wow, I was kind of expecting a few more people than that. But I guess maybe last month was a little bit sparse, but we had a good meeting while we were here, so I thought we'd start out with top 10 best things about staying in Austin instead of going to RailsConf. Why not? So, number 10, a good Keith Gaddis rant is better than the DHH rant any day. Number 9, I can continue to believe that DHH and Uncle Bob are totally BFFs. TDD, anyone following that? Instead of being surrounded by a MacBook toting, t-shirt and sneaker wearing, hipster debating rescue versus sidekick, I can be surrounded by MacBook toting, t-shirt wearing, sneaker wearing, hipsters debating torchies versus Taco Deli. Screw it, who am I kidding? I wish I had gone. All right, so tonight, if this is the first time you've been to Austin on Rails, you might need to know some of the basics. If you need to use the restroom at any point, you just go straight through these double doors and then to the right. The men's room is to the left, ladies' room is to the right after that. General agenda here. Starting with announcements, then we'll move into the beginner's talk, a little bit more basic, then we'll break for a bit. We will have an opportunity if you are looking for a job or you are offering jobs, maybe you can get together and chat and see if y'all can make a match. We'll also have a raffle. I believe we have a couple of books up here. We have 3 books to be raffling tonight. So after the first talk, if you want to come up here, we will set up a raffle on Raffler and get those raffled off. We will then move into an advanced talk, and afterwards we will head on down to BD Riley's for a little beer drinking and chatting and stuff. I'd like to thank Capital Factory for letting us do this. They had continue to be a kind of tremendous unifying factor in the Austin tech community, so thanks for having us here. Do we have any announcements, any sort of events, conferences, etc.? All right. Raise your hand if you're looking for a job. All right, so keep that in mind. Raise your hand if you are offering a job. So quite a few on both ends of the spectrum. So when we have our break after the first talk, maybe y'all can remember who raised their hands respectively, and y'all can chat about that. Tonight's first presentation is from Patrick Morgan. He is an employee at CabForward here in Austin, one of the premier Rails consultation shops. Let's see, Lance Vaughn, I believe, is the founder and owner of that, and a couple of other CabForward folks in the audience tonight. And he will be giving a talk called Deconstructing Your Code with Pry. The second talk tonight will be from Lance Woodson. Don't kill me. A talk called Repairing Foundations Without Shaking the Walls. Lance is a developer at PeopleAdmin, has been doing some fantastic work, and wants to share some of that with you tonight. Tonight's food is sponsored by us at PeopleAdmin, as well as the socialization afterwards down at BD Riley's. Hope you'll enjoy it. For those of you who don't know, PeopleAdmin is a SaaS company that provides HR solutions for universities and city and county governments. Doesn't sound all that sexy, but we have a clientele whose mission impacts the world, and we make it easy, fast, and cheap for them to do their jobs better. So it's a lot of fun. We tackle some pretty big real-world problems. We have 700 plus enterprise customers with hundreds to thousands of internal users, and then hundreds of thousands of job applicants use our software every day. We processed several million job applications last year. So the things that we work on actually impact people's lives. So that's how I've been able to justify staying there for so long, I guess. But it's been great. We have a fantastic team. We are also looking for another senior Rails developer to join our team. So if anybody's interested in that, then come see one of us afterwards. And without further ado, I will hand it over to Patrick Morgan.
Hey everyone. Just lost my here. So, here today to talk about Pry, which is probably one of the most fun and important tools used on a daily basis. Oh, sure. Here to talk about Pry today. It's an awesome tool that replaces IRB that a lot of developers are used to using. Gives us a lot more features, and it kind of replaces, it can replace Ruby debugger and replace Ruby debugger to debug your code, and so not very used to giving public talks. Woo! One of the reasons why I love Pry so much is that it really lets you look into your code as it's running. It makes it easy to see what variables you have, what objects you can access. And it's pretty easy to inject it into your code while you're developing. You don't need Rails to use Pry. Pry can be used on any Ruby application, even like Sinatra apps or whatever. But in going through today, I'm going to use a Rails application as an example. So to use Pry, we don't really have to do all that much. We just need to add a few gems to our gem file, and we add Pry, and there's quite a few plugins for Pry that add some more functionality, and we'll be using Bodybug, Stack Explorer, and Pry Rails. Pry Remote is an option as well, so you can connect to a running server process. So we just add a few items to the gem file, and it'll install, and we're ready to go. So I've got a really basic test application here, and went ahead and fired it up here. And so in order to figure out what's going on here, so we just have this field where we can enter in a number or whatever we want. And we see that it's failing. So let's find out how to fix this.
Make the text a little bit bigger.
Oh, of course. So we're going to bring up the controller here. And we know that if we were to look at the inspect the page, we can see that the action being executed is called do stuff. So what we're going to do is add a entry here for Pry. And what we can do is swap over to the console here. And you can see that we've entered the Pry console. So what we see right here is that we are in the middle of a function, and this a little bit bigger for everybody. You can see exactly where we are in the code, line 2, line 12, and let's see what we can do to look around. First thing, before using any tool, it's a really good idea to bring up your help. So all we have to do is hit help, and we have a nice good listing of functions we can use. Another useful command we can use is where am I? So you can see where we are in the call stack. So really don't know what's going on here, just we see some method invocations. So we can use the command show method to actually look at the method. Keep in mind, this will only work in, this won't work for older versions of Ruby like 1.8 and I believe 1.9.2, but if you're using a recent version of Ruby, you should have no problems. So we can introspect functions, arbitrary functions throughout our application. We can also look at modules. Issues here.
No source.
Ah, thanks. Having issues typing one hand. Expect that. But we can go on.
You're gonna hold the mic while you're typing?
Oh, that's fine. Okay, thank you. So this is kind of what we looked at. A lot of the functionality has a lot of these commands have command arguments that we can use. So if we want to take a look at, say, bring up list help, we can bring up only methods, instance variables, which can be really useful. also have, you can also see routes and methods in documentation. And when we're looking at the stack, we can move forward in execution by saying next. So we can move through. And when we're done, if we wanted to exit, we can type either exit or continue. Of course, I've hit this quite a few times, so it's going through. There you go. Another great thing we can do with Pry is actually move throughout the execution chain. So when one function is hit by another, we can see the stack as that occurs. So if we are to add a different breakpoint in another method, we can show the execution stack. You can see here, way at the top of the stack here, we see where we are. And as we look, if we look down, we can see where the execution started. Generally just read through and see where you start. And a wonderful thing is we can jump between places of execution. So if we type frame, and say if we want to go back up to the method called chain1, we're there. And another thing to touch on is we can also set arbitrary breakpoints. So we can say that we want to break on, say, line 21. Breaks to see what breakpoints we have. If we get rid of the binding.pry statements, we will still be able to hit that breakpoint. So here we are at that breakpoint. And we can remove breakpoints as well. Delete. Execution performs as usual.
So what are some of the things about Pry like that kind of led you towards Pry like versus other methods you'd use? Like,
I didn't really see anything else out there that had just the number of features it had. For example, go through other things that are available here. Love being able to see like which what you can touch from where you are in your code. And it it really helps when you're debugging, being able to show the code where you're at. Anyways, that's about it for my presentation here. Again, I'm Patrick Morgan, software engineer with CabForward, and consulting for PeopleAdmin at the moment. CabForward is hiring as well. Y'all have any other questions?
What were the plugins that you used?
Oh, we used Bybug and Stack Explorer. The great thing about these Pry plugins is all you have to do is just enable them in your gem file. So, and you can see them. The great thing with the built-in help is that it will show you all of the new functions available from all these plugins. So the help command is actually pretty exhaustive, and there are a lot of tutorials online for different ways of using it. And you can use as much or as little as you want. For the longest time, I really didn't use the extensive capabilities of Pry, but as you go along, I found out that its debugging capabilities made life a lot better. Thank you all.
Cool. We're going to go ahead and move on to a little break, and let me just show you the books that we have for our raffle. I'll have my laptop up here in just a couple of minutes to come up here and sign up for the raffle. But we have Data Structures and Algorithms with JavaScript, an O'Reilly book. We have Designing for Behavior Change, another O'Reilly book, and HTML5, the missing manual. Not an O'Reilly book, just looks different. So we'll take a little break, and anybody that wants to sign up for that, come on up. Anybody that wants to chat about job opportunities, come on up here as well. All right, so hopefully we had plenty of time to chat, meet some new folks, see what's going on in the Rails community here in Austin. Did the raffle, we got some lovely books. Last chance to use the restroom before we move on to Mr. Lance Woodson, the man, the myth, the legend. What he will not tell you in his bio is that he's an avid outdoorsman, father of 3, and his uncle was the most interesting man in the world. So ask him about that at the bar if he goes. All right, I'm gonna hop off of AirPlay and let you take over.
Okay. Hello, everyone.
Hello.
All right, I like that. Okay, I'm going to start this out with the exact same slide that Jonathan had. I thought I was going to be clever here, and yet he beat me to it. It's not just a mullet, it's like a flock of seagulls on the top and a mullet in the back. This picture really didn't do it justice. I wanted to start tonight just kind of introducing myself a little bit because I haven't been as active here as probably a lot of you. I live out in Cedar Park and I've got 3 kids, 5 and under. That's right, in the house. So I've got 3 kids, 5 and under, so that conspires to keep me away from here. I also turned 34 today in cat years. Thank you. So that means you've got to nod at what I say and laugh at my jokes. Professionally, I grew up in Java land, which some of y'all might liken to growing up in Haiti. And then about 4 or 5 years ago, I got to start working professionally in Ruby, which is just like driving to the east about 50 miles. I actually don't hate Java, I like Java, but now I'm at PeopleAdmin, and I liken this to Beverly Hills. Yeah, my boss is in the audience. I'm working as an architect, whatever that is, right? I like tackling tough problems, and I think this is one of the coolest parts of our jobs, that we get to fondle giant guts. But no, just that we get to really deal with difficult problems that a lot of people don't necessarily, we get to be creative in finding solutions to something that not everybody could fix. But it means we sometimes find ourselves in a predicament, or at least I do. But I usually find a creative solution, hopefully not quite as morally ambiguous as this, but with those 3 kids at home, all options are open. Enough about me. We need to really get to the point of this, right? And that's DHH is dead, right? And he's not really dead, but I wanted this presentation to stick. And it seems like the only way to make a presentation stick is to make some kind of wild, controversial assertion. So this is my assertion. Really, we're here to talk about fixing foundations without shaking the walls. And this is where you're doing work at like the bottom of your tech stack, right? And this is like a challenging class of problems. Like there's so much information about how you do, new development or refactoring, stuff like that. This is like a different beast. And I think it requires a different approach and mindset than, quote unquote normal development. Your problems look something like this. You've got cracks in your walls, pipes are busting, water's going everywhere, there's a draft, your electricity bill's going up. And you can look at all those problems individually, but their root is in the basement, where the foundation is starting to crumble. And what you want to do is something like this, right? You want to shore up that wall or foundation and do it in such a way that nobody notices, so that nobody on that wall or on the other side of the wall has known that anything's gone on, and that's a good thing. You don't want to do this, where you basically destroy the world, because everybody notices that and it's a bad thing. So all of this is going to be framed within the context of work we did last year at PeopleAdmin to stabilize rescue. And I don't know how many people may not know what rescue is. Does anybody need me to explain? All right, I'll explain a little bit. Rescue is asynchronous job processing library in Ruby. It uses Redis as a middleware, and your application basically will enqueue jobs into queues, and workers will pick them up at some later date, hopefully not too far in the future, and run them. And that's it at its core. So what was wrong at PeopleAdmin, we really didn't know. We had a collection of symptoms. We had slow jobs. Slow jobs that had a really bad perceived performance. And I say perceived performance because perceived performance may be at the actual runtime performance, but it also may be the time in queue plus the runtime performance. We had evil twin jobs. You think you're getting one job in queue, but hey, there's 2, and with the interesting results, usually blood pouring out of an elevator. We had our QWOP jobs, the abject failures, and lots of them. And, trying to page through a list of failures, 6,000 items in length, is not a great way to find the root cause of a problem. We had our Amelia Earhart jobs. They set out over the Pacific, never to be seen again. Become one of life's great mysteries. We had our worst class of jobs. These were the unwelcome visitors. These are the streakers at the World Cup or the Super Bowl, right? This is where we have a customer, say Harvard, and a job gets in queued within the context of Harvard, but it winds up sending an email to somebody at Yale with Harvard information. Harvard and Yale don't like each other much. So that's like a no-no. So rescue had almost become a bad word, right? There was discussion of like, do we just scrap rescue altogether and start over with something else? And we ultimately decided to keep it and try and shore it up, like I said previously. So what you're looking for when to know you're starting to deal with a problem like this, you take stock and you see like this upper strata here is all of our applications. And they all rely on some kind of middle layer of services and systems like email and imports and background keyword indexing, etc. And all of those rely on this bottom strata of the reliable and performant background job layer. And when you see something like that, you really should be thinking like, this is dangerous, because it is. All of that stuff is sitting on top waiting to fall on you. You can easily do something like this and, and kill your little brother. And so this is really where your mindset has to change from normal development. And the rest of this talk is really about kind of like how you can change that mindset. So number one, you gotta embrace the risk, right? Some things are just inherently dangerous. Working with dynamite, skydiving, trapeze artists, working on your backgrounding layer. You don't want to freak out. You don't want your boss or stakeholders to freak out. What you need to do is build your safety net, and this is what's going to keep you from freaking out, or your boss or your stakeholders. And a lot of this talk is about this. How do you build a safety net? And a lot of your time in fixing this is going to be in building a safety net and not actually fixing the problem. And I'd go even further to say that if someone doesn't buy into this as a concept, you probably ought to get a new job, because you will probably make the problem worse, not better. But if you get all that in place, you can be confident that you'll come out with a win. You want to let go of assumptions. We did kind of a poor job of this, or I should say I did a poor job of this, because I really didn't know jack about the problem, right? And neither did, sorry, Jonathan, my boss. We thought we knew what we needed to do, or we had like a collection of ideas to go along with our collection of symptoms, but we really didn't know. And we really should have just started with a completely clean slate about our code, about the technologies in play, so forth. The absolute first thing we should have done, and eventually got around to, was shedding some light in production. And by that I mean in production with some kind of analytics tool or metrics, because you can't diagnose what you can't see. And you can easily do more harm than good. And this is going to allow you to quantify your results. And that becomes really important, right? Because if you can't see what you're doing, you have that risk of really making things worse. And so if you don't have that visibility, you're really making change and then hoping and praying. But if you have like this visibility into what you're doing and the effects of it, you can change, observe, and react instead. You're going to need to build this if you have to. We wound up doing this. We built Rescue Clues. This is the first of 3 open source gems I'll talk about within this context. What Rescue Clues does is it augments Rescue to where it will emit 5 different kinds of events for any job that enters its queues. Enqueued, dequeued, performed, started, performed, finished, or failed. So 4 of those 5 will always be broadcast for any job entering the background queue. Now, that just surfaces the data. You have to use a third-party tool for indexing, searching, and visualizing that data. For us, we use Splunk, but you could use Sumo Logic, Elasticsearch, Kibana, probably a few other things. But if you have such a tool in place, you can ask very pointed questions about your system that you're trying to shore up. Questions like, show me all the details about a specific job. Is that even a question? I may have not used great English there, but you can see that what we've done is we've narrowed our search, hopefully you can see it, onto an event hash that gets generated on the enqueue event, and it is in there for all subsequent events. And that allows you to see everything that happened related to a specific run of a job within your background queue. It allows you to ask questions like, show me the time in queue broken down by queue over time. Here we can see a line for each of our queues in production, and we can see that we're going along pretty well. Nothing is sitting idle in a queue for very long, less than 10 seconds, up until about 10:04 a.m. And at 10:04 a.m., something starts happening to where we're getting large times where jobs are spent idle in a queue. Once you have your visibility, you're going to need to identify your problems, and this can be something that's kind of hard to deal with, right? Because you now can see a whole bunch of stuff, right? And you have to find a way to sift through that and find out what's like really important. To me, this really boiled down to remembering the variables within the system. The variables that I'm talking about with regards to backgrounding are things like the different job types, what queues they were allocated to, the number of workers, the number of jobs that may have been enqueued into your backgrounding system within a slice of time. These variables are what are causing the effect that you're witnessing. And I went so far as to actually list them out on a piece of paper so that as I'm looking at my graphs and stuff like that, I could always reference that as like a cheat sheet to be like, what's going on here? And when you do that, you can start to discern problem interactions like this one. There might be a perceived performance problem with the Big Bird job. And so the question is, it's like, does just Big Bird, does he suck, right? And maybe he does, but maybe it's a little more subtle than that. And what you'll find possibly is that Big Bird is allocated to the same queue as the evil Galactic Empire jobs, right? When there's a flood of evil Galactic Empire jobs into that queue, the workers have to chew through all of them before they actually get to Big Bird, pop him off, running. But when they do, it actually runs very fast. So when you have like all of this, you can start to spot these kind of interactions and see how they may be able to be fixed. Sorry, I'm breathing very heavily into this microphone, I know. You're going to need to fix all the problems that you now know why they are there. And this is kind of boring, I think, related to all of this, because this is going to be very specific to our context here, right? Which is background. There's no way around, like, your fixes to your problems are going to be very specific to whatever system you're working on. Some jobs are just really, really bad, right? You do not want this job. We had a job that had a sleep 30 in it. And probably not surprisingly, our minimum runtime for those jobs was 30 seconds. And the fix for this was simply to figure out a way that we could remove that sleep 30, right? And I think there's beyond that is that You probably want to look at your job code first because it's easiest and least risky to simply improve your job code. And it can result in some big perceived performance gains, not just for your smell the armpit job, but other jobs that might be in the same queue. We have issues with resource contention. Your workers are resources, right? We had issues with our customer environments. We're software as a service. We have 3 different environments per customer: their sandbox, their training, and their production environment. Well, somebody could do something in their sandbox environment that might enqueue 10,000 jobs. And our production our workers that knew not the difference between production and non-production would then have to work through those before it could actually get to that production job that actually was important. The fix for this was to split from prod only queues, or just a single queue, to prod and non-prod. So if there was an emails queue, there's now also an emails non-prod queue with different sets of workers that will work each. We had a problem with junk drawers. Junk drawer queues where you have the tape job, the scissor job, the pin job, the change job, and the battery job all lumped in there in a mess. And this is a real easy thing to fall prey to because your jobs may be very related within the domain, right? They may logically, if you're thinking about what your application does, they may be very related, but they may have vast different performance profiles or resource requirements. One might need a lot more memory than the other one. And if you lump them in the same queue, they'll wind up having adverse effects on each other. The fix for this was to split into fine-grained queues that allowed us to do targeted management. Anybody like the Smiths? So this problem is where you have queue starvation due to kind of a static prioritization of your queues, right? This is where if your workers are all looking at QA and QB in that order, if there's a flood of jobs into QA, QB will sit there ignored and not get any attention whatsoever. I don't know what I just did, other than destroy the world. 1 second. I think we're starting again. So bear with me, I'll have to get back to where I was. I figured we all could use a little refresher. Okay. Anyway, so we have this problem. This is where you're kind of stuck with more or less resources than you need at any given point in time, right? You kind of have a least common denominator thing going on. And because Rescue has a fairly static prioritization, and it's kind of hard to rig systems that will allow you to balance and shift stuff at runtime. What we saw is that we had different cycles of needs, right? We would have floods, right? And our prioritization needs would change. We'd have day cycles versus night cycles where there should be a different prioritization. Weekday versus weekend. We deal with higher education, so you can imagine the school year has shifting resource needs and user patterns within our app. And also like end of year when people are doing large reports, exports of data, whatever, for like year-end reporting. So to combat these last two problems, we created Qtricks to smarten up rescue and workers. Now, its responsibility is to assign the queue priority list to all workers across all servers. And this gives us global management of worker resources. We can make those changes in production at runtime. And it guarantees us two things if we have more workers than queues. One is that each queue is guaranteed to be the top priority of at least one worker. And two, it works on a weighting system, so you assign queues different weights. And queues of a higher weight appear to the left in workers' priority lists more often than queues of a lower priority. And this really clears up those last two issues that I was talking about.
Where does that, like, is that on the worker that you inject that?
That's correct. So basically, we use Rescue Pool to manage a number of workers on a particular server. And so it's hooked into on Rescue Pool. Rescue Pool assigns the queue list to each of the workers. And then the workers, it consults Qtricks, basically says, I'm spinning up a new worker thread, worker process, and Qtricks gives it back an appropriate queue prioritization list. So now we're kind of getting into those risk mitigation techniques. And because of all that risk, there's really kind of this need for a higher standard of validation before you just push this code. You're inevitably going to think this is like a really good idea. I know I did, like, more than once. And you don't want to be remembered for that. Like Fergie here, like this, you don't want this to be like your finest hour. So you need to kind of take a lesson from these guys, right? You want to go Mythbusters on the problem, and you need to test your theories and not in production. So you build a proving ground that you can break at will. It doesn't have to be exact like production, but it needs to be close enough to where you can, you know, verify some theories of what may fix problems. For us, this meant building Stress Queue. And this is a stress testing framework for rescue that gives you a DSL that will allow you to redefine your background jobs in your application so you can deploy it. But now it's going to work in a different way. Instead of actually touching the database and doing stuff within your app, it's just maintaining the performance characteristics that you define in this DSL. And you can override what queues your jobs are allocated to with this DSL and the rate of injection. And this lets you tweak and experiment, right? You can see, like, okay, what happens if I break out the Big Bird queue or the Big Bird job into its own queue? And you have a pretty good idea of what the effect will be in production before you ever go there. Another risk mitigation technique is system flipping. Has anybody here ever built a feature flipper? There's a few people, yeah. So it's kind of like that, but not. You basically want like a railroad switch, right? You want something that, you know, guides your traffic through your system. And you want to be able to turn it on and off at will. And if you can do this, it allows you a really powerful capability of always rolling forward and never rolling back, right? Because you can deploy with kind of an uber confidence. You have your visualization tools of what's going on in production. So you can make your changes, you can throw them over the fence. You look at those tools. If things got worse, you just flip your switch. Nobody felt too much pain. And then you can just start fixing it. For this, we used just a concept of an override file. If that was in place on a worker server, it just bypassed Qtricks and went back to using a static configuration, low tech, etc. So we could always go back to no worse than before. You're going to want to quantify your results, and this is, again, going back to your visibility tools, and maybe it's becoming apparent how important those are. Right? And this is really important for a number of reasons. Not the least of which is you have no demoable features for any of this work, right? There's no snazzy new feature interface that you can demo to your stakeholders. You're not going to have any of your customers calling you up and saying, wow, I really love that brand new spiffy thing you did, right? Maybe you get the vague report that things seem faster. So being able to really measure the effects of your change is good. So those visibility tools, they allow us to see that so that we can react accordingly. If things got better, you just crack a beer, right? If things got worse, you just hit your system flipper, start fixing what you broke, deploy, and flip it back on. You might even be able to impress your boss, right? Love you, Jonathan. What we were able to do with these statistical tools, or being able to derive statistics from our analytics tools, was basically at the end of all this work, we could show that it wasn't for naught, right? So you could say that total time that people spent waiting on jobs decreased 31%, 72% for the worst offender. The total time in queue, the time jobs spent idle in our queues, was decreased 68%. Production time in queue decreased 74%. Stuck jobs during floods were eliminated, and we eliminated one worker server altogether, or one full-time worker server. And that's basically all I have for the slideshow part. I am going to do a live demo, but to recap, change your mindset, embrace the risk, let go of assumptions, and recognize this is different. Obtain, build a tool that gives you visibility in production for your diagnostics, and so you can quantify your results. Obtain and build the tools you need to mitigate the risk, some kind of proving ground and system flipper. You need to fix the problems, obviously. And then you deploy, observe, and react. Lastly, before demo, I just want to give a quick shout out. Josh Flanagan helped a lot. Monty was our QA team lead. He helped us out, and he basically followed me as deep into this rabbit hole as I wanted to go. Jonathan, I thought, showed a tremendous amount of leadership on this. Sorry, I really do want that raise. But he let us, fix it the right way, but also release open source gems, right? And hopefully not just make this less of a problem for us, but maybe less of a problem for other people as well. And I think that says a tremendous amount about, how he wants to build the development team at PeopleAdmin. Matt Bridges paired a lot, and Carl Brassick helped as well. Many other people. So I'm going to do a demo. I'm going to quickly go through what you're going to see. There will be a stress test server that will be doing the stress test, a console by which I will be creating floods of jobs on top of the baseline of activity by the stress test. Got 3 worker servers. Anywhere we're using rescue clues will be emitting those events to a log file. Qtrix will be managing the queue prioritization on all the worker servers, stress queues used for the stress test, and Splunk will be indexing those log files and sending them to the search application. So now I get to juggle a microphone and live code at the same time. If somebody could hold a mic, that would be beautiful. Thanks, sir. We'll see how awkward this is. Yeah. I was trying to think of a good duet to start singing, but I don't know. Anyway. Good. All right. So, the first thing I'm going to show is kind of like what our DSL looks like for stress queue on this initial run. Thank you. I think you can see we have 4 job types: audit jobs, email jobs, import jobs, and export jobs, and they're all assigned to the whole enchilada queue. We also have 15 workers spread over 3 servers that you can see. Maybe if I can grab this little thing here, there. So you can see, yeah, everything's listening to, and trying to work jobs on the whole enchilada queue. So the first thing I'm going to do is just start a stress test. Then we'll see what this looks like in our visualization tool. Maybe. Except I probably have to log back in. Oh. There we can see, I can hold it for a second while I discuss this. We can see a lot of different things here, and I've got several panels that I'll start. Can everybody see that pretty well, or do I need to zoom in? I'll assume silence means.
Probably zoom in and pan somehow. I'm not sure. Can you guys read the titles?
Okay, I'll zoom in a little bit. How's that? Better?
Oh yeah, much better.
Okay. So I'll kind of go through each of these graphs that we're seeing in Splunk. This first one on the top left is the time in queue broken down by queue. And we have exactly 1 queue, so we have 1 line, the whole enchilada.
What are the units?
So, sorry, 10 seconds.
Okay,
So,
10 seconds.
yes. So we can see that our baseline of performance is something, probably on the order of like 1 or 2 seconds. If I hover over any of these in Splunk, we can see the actual time for the peak. So it's less than 1 second. We'll see over here, it's a similar graph, but it's broken down by job type. And we'll see that everything is relatively the same in terms of the time it's spending in the queues, less than 1 second, which is good.
Each point is 1 job.
No. Each point is the average time in queue for however many jobs there are within that bucket of time. So I think it's a 5-minute bucket of time that I have graphed here. So it's an aggregation of the count within that time slice. Now down here on the bottom left, we have the number of in-queued versus de-queued over time. This is a count, not an average of time. So as long as your 2 lines, the number de-queued by in-queued are relatively close together, you have acceptable worker resources for the number of jobs on hand. If you start getting too many jobs for the number of workers you have, those lines really start to deviate, right? And you'll have a big line of in-queued and a smaller line of de-queued. Your workers are not keeping up. Over here is a similar graph on the bottom right, but it's just broken down. It's just the in-queues broken down by job type. And we have 2 more graphs here. This is just the average time to perform for all whole enchilada jobs, and you can see they're all, 1 second or so in length to run. So they're running pretty performantly. Lastly, over here, we have a stacked bar graph over time, where it's the number of jobs that finish successfully within a time bucket, and then the number of jobs that failed within that time bucket. And Splunk gives you a really handy ability to simply click on one of these and it goes to a search for that, if I can actually highlight it and click it. So this is how we can start to drill into what exactly happened. And so we can see all those events around a specific job. We found the failed event around this particular job. If I expand the metadata, we see we have this event hash. We've got the backtrace, and that may be all we need, but maybe we want to know everything there was to know about that job, where it was in queued, right? How long it was in a queue. So if we click on our event hash, and Splunk is not smart enough to completely do this for us, but we'll modify our search a little bit. to basically see all the events related to this particular run of the job. This is harder than it looks. Yeah, thanks. Okay, here we can see that we can see all four of those, or I guess three in this case. I probably need to change it probably came in at a different date or time. So if I change my earliest time to say 40, I'll probably get all the events related to this. And there's all four events. We can see when it was in-queued, and all the metadata about that, including the host that it was in-queued on, the dequeued event, performed, started, performed, and failed, sorry. So now I'm going to show why you don't want coarse-grained queues and how this looks in your test and your kind of proving ground type of environment as you play with stuff. Sorry, y'all. So right now, I am just changing the DSL out on all the servers, maybe. Yeah, thank you. And I have even more typos. Okay, I'm also going to change the Qtrix configuration. And if we look at what this looks like now, what our weighting and stuff looks like within Qtrix. You'll see we have audits with a weight of 4, emails with a weight of 3, imports with a weight of 2, and exports with a weight of 1. I have not shut down any of those worker servers or anything, but we can see that maybe we can see if I can actually click a button that we now have a mixed up prioritization of queues. If you look closely, you'll see that all of those queues are at the head of at least one list. Audits, imports, emails, exports. You'll see that audits are at the head of the list more often than the emails, more often than the imports, more often than exports. So now, if I do a stress test, we'll see, I want to show what the DSL looks like now. And it's very similar to what it was before. The only thing that have changed is all these jobs are now allocated to really fine-grained queues. Exactly 1 queue per job. There's no longer a whole enchilada queue. Thank you. So I'm going to simulate a flood of jobs using the console, which is riveting. Okay, we can see new data coming in our dashboard now. We can see that we're using more fine-grained queues. We no longer see stuff going into a whole enchilada queue. We see audits, emails, exports, and imports. Otherwise, things look pretty much the same as they were before, with everything having a queue time of roughly under a second. Hold on, I need to back up 1 second. Sorry, I left out the step of showing what a flood looks like in a really coarse-grained queue scenario. Okay, we're going to see some interesting things in our analytics now. You see we get this huge spike of jobs in queued, and this is in the bottom left, right? If you mouse over it, we can see that count, and oh, there's 1,000 jobs that were in queued in that time. We also see an interesting pattern in here in our time in queue. And again, this is back to the whole enchilada queue and not the fine-grained queues. But we see this envelope pattern, right, where our time in queue is increasing over time. It's because all those jobs that got flooded into the system are sitting there waiting for a worker to come by and pick them up and do something. Also, over here, you'll see the only thing that's getting dequeued and worked are email jobs. None of these other job types are getting dequeued and worked. They're sitting idle in their queues, waiting for a worker to come by and give them some attention. And this is kind of, a symptom that we saw a lot of, or when we started getting visibility tools, stuff that we could see going on in production that led us to some of these conclusions of how we fix it. Right now you can see we've hit our crest, I think, or we're close to hitting our crest of the flood, and you'll start to see, a drop off and the other job types starting to be dequeued and performed as we've chewed through the 1,000 email jobs, and now we can dequeue the other jobs and start working them. And they have a similar high time in queue. So now we're going to test a theory in our proving ground to see if we fix that, or if we have a solution that might fix it.
So this is showing the junk drawer approach, where a whole bunch of different job types are in the whole enchilada queue.
That is correct. So I won't go through and re-demo or re-show what everything looks like. I'll assume you can, you remember that we have really fine-grained queues now. I won't go through and show the DSL. So now we're back here with where I should have been, which is we split everything out into really fine-grained queues. And so we see on that top left, instead of it being a single line, now it's like multiple lines showing how long each jobs in each of those queue types spend in a queue. So now we're doing the exact same flood scenario, and we're going to see something different happening. We have this same spike in this bottom left graph of enqueued versus dequeued, right? Where we've enqueued 1,000 jobs. That immediately drops off. But up here, we're seeing something very different. We do see that envelope climbing pattern, right? But it's only for emails, right? It's not for these other queue types, right? Like audits and other things. They are actually getting run within this flood scenario. We no longer have this big gap where we're waiting to chew through all of the email jobs before we can start, working these other things. Now, you still have the problem that you have too many email jobs for your system to deal with, and that's where you need to spin up new workers, things like that. Qtrix is smart in that way too, in that if you bring new workers online, they'll automatically come under the auspices of Qtrix, which will assign them their queue priorities appropriately. And but this has eliminated any sort of perceived performance problems that people might have felt within our system. So that's basically it. That's the demo. That's what I have. The one thing I'd like to just kind of finish up with is, hopefully this showed how you might be able to take a visibility tool and a proving ground, test some theories, have an idea that how it might work in production. You get to see what you should see once you deploy to production, right? And if you don't see that when you deploy to production, then you've broken something or made a regression or it just didn't work how you thought. And this is exactly what we saw, for this kind of class of problem when we deployed to production. We basically had all these benefits and goodies. So that's it for me. I guess I'll turn it over to this man. What? Oh yeah, sorry. Questions. If anybody has any questions, I'd love to hear them. Sure.
So you said you eliminated stuck jobs. I'm curious, what were the reasons you found that they were stuck, or did you ever figure that out?
Yeah, so when I said stuck, it was not so much that they were stuck forever. It was more that this kind of problem, where they were stuck behind a flood of jobs and wouldn't get worked for some period of time. The way this manifested in production was there might be a scheduled export that needed to run at a particular point in time, right? And it never got run until 6 hours later, right? And that was beyond some time window of acceptable SLA performance, that type of thing. So it wasn't that it was stuck forever. It was more that it was just a problem with contention within coarse-grained queues or contention between workers over different job types, that kind of thing. Any other questions?
I'm kind of curious. How did you figure out the client email issue of getting it to go to the right?
Sure.
Getting to go to the right client.
Yeah, that was a fun one. Well, we actually used rescue clues for that, and gave us the ability to see that was happening only around deployments, and that led us to dig in further. And what we had was improper connection handling to Redis across forks of worker processes. And so we had to actually debug that issue in production using these tools to, make sure we were correctly handling Redis connections across those forks, because it was like a shared file descriptor. And so you had jobs, might be two different processes, but they were sharing the same connection file descriptor at the OS level that was causing them to step on each other. It was a difficult problem, and we could not have figured it out without these kind of diagnostics and visibility tools. Anybody else? Okay, that's it.